Hello everyone, my name is Karen Ventimia, and I'll be presenting my contribution to this team's project over the semester. So starting off, I'm just going to start with the first class I made, which is the parameter class. The purpose of this class is to be able to create parameter objects when parsing our JSON file. The parameter object will consist of the parameter name and the list of equivalence classes it has. And the goal is to use the parameter objects to create all combinations of equivalence classes for each parameter later on when we use our combination algorithm. So just going through our code, pretty much it's just a standard file. The instance variables are called string name and an array list of type string equivalence classes. The name is just the name of the parameter, and the array list contains all of the equivalence class names. Then we have just a default constructor that initializes default values. This is to help us when creating parameter objects. And then I guess the one method that we did add is to add a method to add parameters to the array list. So basically it's just a simple method that just adds the equivalence class name to the equivalence class array list. And then the rest is just getters and setters. This just helps us, set different parameter object names in the equivalence class list. So moving on, we're going to move over to FileParser. So the first part about this class is it's supposed to have the ability to parse a JSON file in order to create parameter objects. These parameter objects will hold the name of the input parameter in the file and the array list string of the equivalence classes for the input parameter. This class is also responsible for creating all possible combinations of the equivalence class. And then the goal is to take this class and use it in the front end in order to process the file input by the user, which I'll demonstrate a little later on. So starting off with the file, we have to add this server annotation here. This is just so Spring knows that this is part of the service, so it knows to come here and make sure to get the information from here when it's called. So we have to include the service annotation here. It has a basic just default constructor. It doesn't really initialize anything. It's just to allow us to call file parser methods from inside this class. Before we get into this create combos method, I'm going to skip down to this parse file method. I originally had used this, but Puen had gone in and changed it to his code, so I'll just explain the gist of it. This method is to parse the JSON files. It'll add the input parameter name and the equivalence classes and create parameter objects using these. Once one of the parameter object is made, it will add it to the array list of type parameter, right? So this method is pretty much used to parse the file and then generate an array list containing of all parameter objects. Basically, all the coding here is Puen's, but the idea follows the same concept. It has the keywords, input parameters, and the equivalence classes. I'll have Puen go through this and explain it in his individual video, and I won't take it from him. But ideally, the same thing is the same, or the method does honestly the same thing. So skipping back up to our create combos, I'll just go with what it's supposed to do. So basically what this method does, it creates a matrix that holds all the combinations of equivalence classes. The matrix is made by setting the rows to the amount of combinations and columns to the amount of parameters. So basically, if you had combinations that would amount to 16 total combinations, there would be 16 total rows. And if you had 3 parameters, you would have 3 total columns. That's essentially what that means. And then the algorithm populates the matrix from bottom to top. You'll see this a little bit later on. And then the parameter array list represents an array list that holds all the parameters. And you get this parameter from the parse file, method. And then int count is logic that is passed in before this method is called. This count is used to obviously create all the rows for the matrix. So that's why it's passed in here. Before we get into all the code and stuff, let's just go over the logic of the algorithm first. So I have this pulled up here that I just wrote down so you guys can visually see it. So here we have a sample text file of what a user would see if they inputted a file. And here's the algorithm logic itself. So going through the logic, n, as you see here, represents each parameter. So n would just represent like 1 parameter, 2 parameter, 3. Let me rephrase that. N equals the current parameter. That's what n means, and you'll see that later on when we go on. Size equals the number of equivalence classes. and then x equals the nth parameter. So if you were to have, just for the sake of making the algorithm clean, if you were to have 16 parameters, x would just represent, numbers greater than 1, 2, or 3 here, because, I don't have enough space for all that. So there's a note here that I listed. It says use the last parameter as a starting point and decrement backwards. That is because the way the matrix is populated, it starts at the last row, last column, and it starts at that element, and it works its way up from there. It decrements backwards. So that's why you have to start using the last parameter. So the algorithm is pretty simple. What you can see here is logically or visually, you can see how if you look at this last column, it changes every one, right? So never run, completed, running, ready, right? We know that this last column is always changing by 1. So what we can do is we can set the first change equal to 1, right? And so by doing that, we can just see it, constant change, right? So we'll just set it to a constant value of 1. Moving on to the second parameter, we can see it changes every 4, right? So it goes, for the first 4, it's web execution, and then the second 4, it's Jarvis, and then it switches back, right? So every 4, it'll switch. So the way we can calculate that, right, is to take the result of n1 and multiply it by the size of n1, right? So I'll show you later on, just by doing the calculation itself, how you can get this math completed. And then finally, you just keep doing this pattern. So for the third one, you just take the result of n2 and multiply by the size of n2. So moving on to an actual example using the same file, we will start with the result of n1, which is right here, the second part of the algorithm. So you start with the change in n1, which is 1, times the size of n1, right? So the size of n1 is 4, right? Because we have 4 different equivalence classes. Excuse me. So we do 1 times 4, right? Which equals 4. So change in n2 equals 4. Which you can see here is 1, 2, 3, 4. 1, 2, 3, 4, right? So now we have to figure out what about the last one. We can visually see it changes 8, but how do we get that on paper? So what we can do is follow the algorithm. So what we can do is take the result of n2, which is 4, and multiply it by the size of n2, which if looking here, the equivalence class size is 2. So we do that, equals 8, right? So based on that information, what we can see is the last one changes every 1, the second one changes every 4, and then the third one changes every 8. And essentially that's what the algorithm does. So moving back onto the actual code itself, the first step is to use this param list array to store all of the different equivalence class names array list. So what it'll do is essentially it stores the strings of each parameter's equivalence classes. So if there was 3 parameter objects, it'll store each object's array list of equivalence class names. That's essentially what this is doing. And then this little for each loop populates the, or enhanced for loop populates the param list array list with the equivalence classes. Essentially what I was just saying, it just takes the equivalence class array list and then puts it inside of this array list. So moving on to all the initializing of like variables that we have to use inside of the while loops. The first one we're going to have is int total params, which is rlist.size. Essentially, this just gets the amount of parameters, right? So if there is, going back to our example here, we would have 3 parameters, so the size would just be 3. Or total params would just be 3. Int current param equals paramlist.get total params minus 1.size. This is the equivalence class, so when we're going through this for loop, we're essentially or when we're going through, this for loop right here, we're essentially using the current parameter as our checkpoint, right? So, and then we have these variables here, int change equals 1. This goes back to our algorithm here. This is where the first change comes in, right? Essentially, that logic is set to 1 instead of 0 because when I have to do this int check change, if I have change set to 0, the math wouldn't check up to be the right number. So I set it to 1. And then I do change equals change times current param, which you use this to exit the change loop and reset. Essentially, I'll explain this later on. Then we have this matrix created, and it's basically a string matrix that uses count for the rows and total params as the columns, right? So in the example here, you would have 16 rows because count is 16, and you'd have 3 columns because there's 3 parameters, right? And then we have int temp equals count minus 1. This is a temp variable I can use to constantly reset. Essentially what I'll do is I'll take temp and set it to count minus 1, because if I keep it as count, it'll have an index out of bounds. So we have to decrement it by 1 in order to go from 0 to 15, ultimately being 16 total iterations. And then we have int check equals total params. I use this as a decision maker in the if statement. Basically, as soon as you get out of the first, as soon as you leave the first column, right, the one that changes constantly, you're going to switch logic and start using the algorithm logic instead of using the constant logic listed here. And that's what's used here. Excuse me while I take a water break. Sorry about that. So you can see in this first while loop, total params is greater than 0. So while total params is greater than 0, you can see it just keeps going until every parameter is run through, right? So you'll start at the third parameter, which will essentially be the last one, right? You start at the last one and keep moving backwards through all the parameters. And while that's greater than 0, just keep going, right? Until you get to the last parameter and switch, okay? This loop right here is meant to go through each row. So you'll start at 15, right? And then you'll just move from 15 to 14 and all the way up. We have to put it greater than -1 because there is an instance where there was an index out of bounds where actually it wasn't an index out of bounds error. It was more of it was just not running to the full amount. So we switched it to -1 to fix that error, right? So essentially what this is going to do is it's going to run for each row. It's going to keep going for each row and then populate each element, right? In this for loop, we use J to populate the matrix, and I'll show you a little bit later when we get down to the actual matrix population code. If check is not equal to total params and total params is greater than 0, pretty much the logic here is basically saying, pretty much what this logic is saying is if you're in the first column, move down to here. If you're in the second column or any column after the first column, well, let me rephrase that. So if you're here, right, I'm saying first column because it's the last one, or it's the first one we use, but in actuality, it's the last one. So if you're using the first, I guess let me just say last param. If you're using the last param, right, you're gonna skip down here and you're just gonna do the constant update, right? You're just gonna skip down here and you're not gonna worry about any of the algorithm logic here. After that, this Boolean expression will change to false, or excuse me, it'll change to true, and it'll start going in here, which in here is where all the algorithm code and logic takes place, right? So basically what this if statement is doing is checking to make sure if you're in that last column where it changes every 1, or if you're in any other column where it has to change based on a different value, right? So once we get to a column that's not the last one where it changes every 1, and we move into another column, we're going to reset change equal to 0, because if we leave it as 1, you're going to have a problem where you're going to move through them, but you're going to skip one on accident. Instead of going 0, 1, 2, 3, 4, or excuse me, 0, 1, 2, 3, 4, it's going to go 1, 2, 3, and then switch instead. So we have to reset it to 0 in order to start from the last one, or the first one, and get all the way to the correct number, right? And so while change is less than check change, and so as you can see, change is change times current parameter. So it'll be check change after the first one would be this part here. So after you get through the first column or the last column populated, you'll do this math here, and you'll get check change to equal 4, which I should have explained that first. So let me do that. So regarding everything I said here, so after going back to the last column here, after this whole column is completed, what it'll do is it'll exit this while loop, right? It'll move down here. It's going to reset temp, so it should start back down at the bottom and work its way back up. It's going to shift the column over to the next parameter, right? So it's going to move from this last column over to the middle column. And it's going to set check change equal to change times current param, right? So current param is current param is 4, right? And then change is 1, which is set here. So it'll just be 1 times 4, which is 4, right? And then basically what this doing is used to update the current param while the total params is greater than 1. This is just to help us reset the total amount of parameters there, or a total amount of equivalence classes for that parameter. And then once that's done, it's going to skip all the way back up here again, because while total params is greater than 0 is true, you're going to skip down here again. So just re-going through it, this is now going to be true because check change is no longer equal to, or check is no longer equal to total params, because check equals total params, which is 3 at the start, and then now total params is like 2. So this is no longer accurate. So we're gonna skip. We're gonna skip in here. We're going to set change equal to 0 so we can do the math later on, or not do the math, but so we don't have a problem with the indexing. And then we're gonna move into this while loop. And while change is less than check change, which we can see 0 is less than 4, right? Because we did the math down here, 1 times 4, and I can show it again over here. This is essentially the check change, so 1 times 4 equals 4. So while change is less than 4, which is 0 less than 4, you're going to do this. So param temp, so param, and then row number, and then column number, equals param list dot get total params minus 1 dot get j. Essentially what this is doing is it's going inside of a parameters equivalence classes, and it's getting the jth equivalence class. So example, for the last one right here, it'll get j of 0, right? Current param of 2, right? Or 1 in actuality, because it's minus 1, so it'll be 1 and 0, so it'll just get a Jarvis execution, and so on. So you're going to keep doing this, right, based on the change. So while 0 is less than check change, this should run 4 times, right? So if you go back to the thing, you can see it runs 4 times. So after it becomes false, it's going to exit, and it's going to come all the way down here, or it's going to exit, and then it's going to just reset again, right? Because this is going to be true again, and it's just going to reset, right? And it's going to keep doing that all the way until you get to the last one. And essentially that's what the algorithm is doing. It's going to do this until all the matrix is populated, and then finally, once it's done, it's just going to return a param array, which is the param matrix, which will be used later on when creating the text file. So moving on to some more code that I wrote. This is code that was imported from Spring using the import stuff that they have in Eclipse. Basically what we did, we just added our file parser constructor, and we also set it inside of the constructor, or excuse me, we added our file parser object, so we can use the methods in here, and then we just added it inside of the controller constructor, so it's initialized. Scrolling down a little bit to the part that we really modified. Going in here, Michelle and I started writing the code to write to a text file. Basically, what this first part does is it gets the name of the file minus the .json extension. So when we have to write the new text file, we can use the name of that one and add on further text behind it. When Michelle and I all had some hand into this, basically what's going on is we're going to store the multi-part file that's parsed in, and then we're going to access that file. Well, before we do that, we're going to create a new file object inside of the upload directory, and it's going to be the file name without the .json extension, and then it's going to add -combos.txt, right? So if you uploaded the file, I think I have an example already in here, execution queue on save.json, your text file will be execution queue on save -combos.text. Here is basically just creating the buffer divider so we can write to the file. This is all what this does is it uses the parse file to populate an array list of parameters, right? So it will parse the file inside of the directory, and then we'll set it to an array list, and then we'll have the variable count here, right? And what we'll do is we'll write to the file all of the parameters, names, and equivalence classes, and while we do that, we're going to calculate the total amount of combinations, or count, I should say. And the way count works is count times temp.getEquivalenceClasses.size. So for example, it starts at 1. So what it'll do is it'll multiply 1 times 4, right? So it'll be 4, and then it'll be 4 times 2, which is 8, and then times 2, which is 16, right? And that's how count would be 16 in that case. And then moving on, we'll just write a new line here, which you can see, in this gap right here. And then we're going to create our matrix, right? In order to create that, we're going to pass in our array list that's populated right here in this line 100, populated in here. And we're going to pass in count that is passed in or updated through this for each loop. So once that's done, we're going to start writing to the file. This little bit of logic right here is basically used to make sure the spacing is all in uniform index. So if you can look in the file, all the lines for the parameter or equivalence class name start on the same index. This is so it's just a little bit easier to read, because sometimes there's instances where there's over 100 test cases and we don't want it all to be zigzag and hard to follow. So what we did is we just made sure everything starts on the same index, and then we just write the also before I get to that, we also added this so it writes the test case and then the number. This is also easier to know the total amount of combinations is correct, as well as making it easy to identify each test case individually. And then once we do that, we're going to write each row of the matrix into the file. So what it'll do is it'll just go in here, it'll get the row and then the column number, and it'll write an element and do it and do it and do it, and then it'll go to the next one and so on, right? That's how it writes here. Then we're going to write a new line at the end just so we can get to the next line, and so it's not all on the same line. So it's not going test case 1 and then test case 2 right after it. It's all going to the next line, right? And then we're going to close it. This exception here, what this does is if while we're trying to store a non-JSON file in this part right here, what it does is Point made it so that if you uploaded a JSON file that's not or you uploaded a file that's not JSON, you'll get this error message which returns error or cannot store non-JSON file, right? And then essentially what this does right here is it returns a flash attribute saying you successfully uploaded a file and received file name, no extension, or file name with the dash combos.txt extension. So that's pretty much all the code I was part of. So let me just do a brief demonstration of pretty much everything. I'm going to use the localhost. We have our actual website launched, but the problem is I don't want to mess with it right now because we're still trying to figure out if the server resets daily, and if so, that'll be good news, because right now if someone else was to upload a file, I would be able to see the file that they uploaded, which is obviously a problem. But if it resets every night, the files themselves would get deleted, because on server launch it calls the method to delete recursively, and it'll help get rid of all the files. So that's just one issue, but I'm going to use the localhost right now. So let me choose file. Let me just choose a different one. Let me choose something that I know has a lot of parameters. So I'm gonna do this one. I don't know, this one might have over a few hundred. Let me just see. So as you can see, I uploaded an expression example with recursion, and I got this output right here, expression example with recursion dash combos.txt. So I'm gonna click on that to download. I'm just going to open it, and as you can see, we have hundreds of parameters here, 400 or combinations, 486 total. If we wanted to, we can visually see how each one is supposed to change, right? So if the last one changes every 1, right, we can say the second one should change every 3, right? Because it's based on 1 times the size of the previous parameter, right? So 1 times 3, which you can see 1, 2, 3, 1, 2, 3. 1, 2, 3, and it changes every 3, right? The next one, 55, 45, 35, 25, 15, 5, 85, 75, and 65, right? This one should change every, let's see, so 3 times 3, so every 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and it switches 1, 2, 3, 4, 5, 6, 7, 8, 9, and switches, and so on, right? So you could do the logic itself and you see how it's all correct. So yeah, that was just another example of how the test case algorithm works with the combinations and everything. I did write some tests, so I guess I can go over that real quick right now. So let me do that. Let me go into our test package. I wrote a couple tests. So I wrote tests to test the FileParse class. Essentially, I'll just run everything at one time. Run test FileParse. So as you see, every test passed. So this first test right here is the test FileParse constructor. Actually, no, this one is to test the FileParse method. Basically, what it's doing is once you've parsed the file, you should return an array list of parameters. So if what we do is we assert true that the array list size is greater than 0, and if it is, we know that it's correct. And if it's not greater than 0, there should be an error parsing the file. Essentially, that's what's going on in this test case, or this test method. This method tests the create combos method. What it does is it creates the array list of parameter, right? And then it updates the count, right? Because these are the two parameters that need to be passed into the create combos method. It creates the matrix and passes in the two variables. And then it asserts true that the combos.length is greater than 0, right? And if that's the case, we use this to indicate that if the length is greater than 0, that means it's all populated, it's all created perfectly. Essentially, that's what's going on, right? Because the matrix here isn't set to any value besides the one that's returned from the file parser.createCombos. So that's why we use the createCombos.length greater than 0, which indicates if the matrix was populated correctly. This method here, test count parameter, that essentially does the same thing, except instead of testing the matrix, what it's going to do is it's going to test the count parameter that's incremented. So in this case, execution queue on save, if I go back, there should be 16. The count should be 16, which is 4 times 2 times 2, which is 16, right? So we assert true that count is equal to 16, and if not, we have an error updating parameter count, right? And finally, we're just going to check the check file type limitation error. So if we're trying to store a file that is not JSON, let's make sure that we throw the error, right? So essentially, what we'll do is we'll just create a file name, just a test one, testfile.txt. We'll take the integer, the last index where the dot starts, right? And then we'll take the string extension, and we'll pretty much just get the dot and then txt part from this. And if the extension does not equal JSON, throw the file error part, right? And essentially, what this does is it returns true because .txt does not equal .json, therefore it should return, or it should throw the error, right? And that's essentially what's going on. So out of this class, that was just to test the file parser. I did write some tests to test the parameter class. The first test is test getters and setters. Nothing too crazy. The getters and setters are specifically for the get name and set name. Just easy stuff. Same thing with the equivalence classes. It's just assert equals uses assert equals to make sure that the list that was created from here is equal to the list that's here, right? Here's the one that really matters, because getters and setters are usually auto generated, so there shouldn't be any errors with that. But the one that we did create, at test void test add param. This test is our add param. So when adding a equivalence class name to the equivalence class array list, right? So essentially what we do is we'll just create a parameter object. What we'll do is we'll create an array list object so we can add strings to the array list, right? So what we'll do is we'll set the param.setName, param.set equivalence classes array list. We'll add that parameter to param list, a new parameter list, right? Or a new array list, I should say. And we'll add param_list.addParam, which is this part. And we'll just assert that all that stuff is equal to the same thing, right? Yeah, that's essentially what this. So let me just run this class real quick. And you can see all 3 tests pass. So there you go. And let's get to the fun part. Let's move over to the automated testing using Selenium. I'm going to do all these individually, but before we get into it, what we have to do is we have to make our WebDriver instance variable so we can initialize it. Before that, we have to use the before all, and we have to set up the property for the Windows or the Chrome driver and the location of where it's in my computer. And then driver equals new Chrome driver, just to set a new instance variable, right? So this first one, so if I go back to our website, we have this example JSON file. When you click it, it should bring you to this page, right? So what we'll do is we'll just test it. So I can hover over this, and then I can just make sure I'm there. And then, as you can see, it says webpage test.test JSON filing. So when I run it, let's see what happens. See, it pops up the new page, and you can see it brings us to the example test case or example JSON file. So I'm gonna close that, and I'm gonna move on to the GDC link. And there's a GDC link at the bottom just in case a user wants to learn more about Georgia Gwinnett College. So let's go ahead and run that test. And you can see here the GDC web page is pulled up. So that link is validated. And then we have a test user guide link. And what this user guide does is it explains to the user how to actually use the API itself. So if I click on this link here, it should bring you to this page. So let me just go test that real quick. And you can see here, it brought us to the page where the API guide is. Cool. And then the last, or I guess not the last one, but for the test upload file, right? What we're going to do is we're going to test the ability to click this button here and click this button here. Essentially what's going to happen. So as you can see here, the file here that was uploaded, you can see how it's this one right here. You successfully uploaded execution queue on save.json and received execution queue on save-combos.txt. So that's that. And then the last one is just testing the download link. So if we go back to our local host, it should it should download the execution queue on save-combos.txt. So let's go back and let's run it. And as you can see, the file is downloaded, and if we open it, here's all of our combinations for that class. I also have one listed here, so as you can see, if we compare them side by side, you can see, but sorry about that. You can see how the everything's the same. So yeah, that's basically what I did for this project. I hope you guys enjoyed. Yeah, thank you for watching, and I'll see you next time.